Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 5. I'll be covering question number 21 to 25 in this episode. We'll get started. Question number 21. Users may get past performance report from a company's website. The website requires a solution that can grow to suit the company's worldwide website requirement. The solution should be cost-effective, minimize infrastructure resource provisioning, and deliver the quickest reaction time feasible. Which mix of technologies might a solution architect propose in order to satisfy these requirements? So let's understand this problem. What we have here is a company website. Let's assume a company like Apple, and users are trying to download past performance reports from this company website. As Apple, every quarterly or on annually, whenever they publish their results, obviously all the investors, shareholders must be interested in knowing how the company is performing, and they're downloading some reports. So this is just one example. It could be any other website which has some sort of reports. For example, maybe a credit check report website where users are checking their credit history and then generating a report and downloading it for forwarding it to financial institution or for their own consumption. So any kind of website where the main content that is being consumed is some sort of static reports. And this website, the users are all over the globe. So it's a worldwide access requirement here. So everybody's accessing this website, and we have, for now, created a empty box because we don't know what is the technology on which this website is built. But yeah, as you can see, the users are from all over the world are accessing this website and downloading the report. And what we want is we want a cost-effective, minimize the infrastructure resources, and a quickest reaction time. Now, we have done this in past. Whenever you need, say, static reports, you want minimum latency, and you have a global requirement, make use of S3 and CloudFront. And that's the solution here. It's a straight application of S3 and CloudFront combination. CloudFront, from its 540 locations worldwide, will be able to deliver content near the user. This is a static content. We are having global customers, and we need minimum latency. CloudFront and S3 is the perfect solution. So that's what we have here. This is one example for you. This is from AWS documentation regarding how WordPress site has implemented a solution with the help of CloudFront and S3 buckets to accelerate their website access and minimize the latency. So it's almost similar to what we have in our problem. On top of they have also mentioned a Route 53 service for DNS mapping. But this will tell you that our example, which is a similar scenario, is no different than this, and the solution that we have chosen, CloudFront and S3, is the correct one. Now let's go to the problem and maybe select the correct option, and then we'll also see why the incorrect options are incorrect. So we already know our solution for this particular problem is Amazon S3 and CloudFront that we already selected because it's static reports. Let's see why other options are incorrect. So option B, it says AWS Lambda and DynamoDB. Now, Lambda is serverless and cost effective. For dynamic content, it's fine, but for static report, we don't have a case for DynamoDB as well as AWS Lambda. Option C, ALB and EC2 for auto scaling. Now, this option involves managing EC2 instance, which can be complex and it would add cost. It will scale with auto scaling, but it's an overkill for just serving static reports. Whenever you have a static website, static reports, or content that doesn't change to be distributed worldwide globally with minimum latency, we have a solution for that, which is put it in S3, put your website or reports in S3, and distribute using CloudFront. That's the perfect solution. So this is not required. This is going to be an overkill. It's an expensive solution than option A. Option D, it says, let's use Amazon Route 53 with an internal application load balancer. Now, Route 53 is fine. That's for DNS routing. That's nothing to do with content delivery or speeding up the access or minimizing the latency. And load balancer, again, are for distributing traffic. Again, it's not going to help with the performance for serving static files globally. So Route 53 will be used, as you've seen in the case of WordPress, but it's not to solve the problem. That's for just DNS routing. So we got our answer, option A, Amazon CloudFront and S3. That is how you will do any problem related to serving static content, a website which has generally static content or reports or maybe media files which you want to stream worldwide. You go for, store your content or website in S3 and then distribute it using CloudFront. CloudFront, with its global network of, I think, 540 edge locations, it would be able to serve all the content nearer the users, minimizing the latency. Summarize this particular option for your benefit, how regarding how good is this option and on under what parameter. So the first one is scalability. Both CloudFront and S3 are highly scalable services, and they're designed to handle massive traffic spikes. CloudFront has edge locations worldwide, delivering content quickly anywhere. S3 offers infinite storage capacity. So from scalability point of view, these are perfect for the problem that we are trying to solve. Cost effective, CloudFront charges based on the data transfer request, and it makes it economical for serving static content. S3 also offers various storage tiers with performance trade-offs. So in case, it's not just CloudFront, even for S3, depending on what type of requirements you have, you may not need all the reports all the time. Then you could use intelligent tiering or move them to archival to save your cost. So those options are available at S3, which you will not get with any other option. In terms of the third aspect, infrastructure provisioning, both the services are fully managed S3 as well as CloudFront. So you don't have operational overhead for them. And the last one, which is the performance, which is quickest reaction time. CloudFront caches content at edge location, minimizing the latency for users worldwide. S3 is also highly available and performant object storage, and it's good for fast retrieval. So just recapping all the elements of this particular solution so that you can make a note of it, take a screenshot if you like. But remember, any scenario, not just this problem, any scenario that would involve static content, reports, static website, media streaming files to be distributed globally with minimal infrastructure overhead, you should go for S3 CloudFront option. That's it on this question. Let's move to the next question. Question number 22. A solution architect is developing a hybrid application on AWS cloud. AWS Direct Link will be used to connect on-premises data center and AWS. Between AWS and on-prem data center, the application connection must be very durable. Which DX setup should be used to satisfy these criteria? So in terms of problem description, what we have here is we have a hybrid application scenario. We have on-prem data center and also AWS data center. And some of the applications are sitting in on-prem data center and some of the application components are sitting in AWS data center. And it's already decided that this will be connected using direct link connection, which is a good choice. Now, the question that we need to answer here is what setup of direct connect we should be using in order to make the connection more durable. And we have few options here. So let's go each option one by one and figure out what's the correct answer. So the first one is, it says on the existing DX connection, you put a VPN on top. Direct connect connection is highly durable and it has high bandwidth. Adding a VPN on top of a direct connect connection is not going to make it any more durable, and it's just adding unnecessary complexity. So this is a very incorrect solution. So I'll rule that out. Then let's look at what is another one which appears to be incorrect. So option C, it says configure a DX connection using most reliable DX partner. Now, choosing a DX partner is important, but this is not about resources. This examination is about AWS services, and you will never get an option like this as a correct answer. So choosing DX partner is important, but what is more important is what is the infrastructure or architectural design you are using to make the direct connect connection more durable. So this is incorrect, not a correct option. Option D says configure multiple virtual interfaces on top of a DX connection. Now, multiple virtual interfaces on a single DX connection offers some sort of redundancy within that AWS environment, but it will not address potential outage of the physical connection level. I think the right solution is increase the redundancy, add fault tolerance by configuring the DX connection at multiple DX location. That would mean that the overall network is going to be highly fault tolerant. And if a particular data center is crashed or is not available, you can have the DX connectivity from another physical location. So this is the correct option. Overall, this question is not very nicely worded, or options are also not very strong in terms of the correct options or incorrect options. But from what we have been given, this is the best solution, which is basically in line with the architectural principles of adding high resiliency. I put a link for that in video description as well for giving you more confidence around this particular answer. Here is an article from AWS, and they have shown here for creating a highly resilient network in terms of using direct connect. So it's a similar situation here. You have customer data center and you have AWS data center here, and they have in the solution they've used direct connect from location 1 and location 2 in order to make a highly durable direct connect network, so that the overall durability between of the connection between data customer and on-prem customer data center and AWS is highly resilient. So that's it on this question. Let's move on to the next question. Question number 23. A business wishes to automate the evaluation of the security of its Amazon EC2 instances. The organization must verify and show that the development process adheres to security and compliance requirements. What action should a solution architect take to ensure that these criteria are met? And we have few options. Let's analyze this question. So what keywords we have here? A business is using EC2 instances and they want to automate the evaluation of the EC2 instances for security and compliance requirement. So what they want to prove is their EC2 instances are secure, there are no vulnerabilities, there are no issues with it. So if an auditor comes along, instead of running some reports on on-demand basis, you always have a ready report of what is the overall status of your EC2. Now let's go each option one by one. Let's eliminate. I think you probably know the answer if you've done the services and you have gone through the cloud practitioner series. In fact, I would recommend anybody who's doing solution architect and they have not done cloud practitioner recently, go through cloud practitioner series. That would be a quick way of knowing the services quickly. That series is pretty quick. Questions are pretty short, and you could run through that series at a higher pace as well, and then come to solution architect series. Let's go back to the question analysis again. So first option says use Amazon Messi to automatically discover and classify and protect EC2 instances. The purpose of Amazon Messi is to identify if you have any personal identifiable data in your system. It is good for data classification, protection, but it's not about assessing the security vulnerabilities or compliance adherence. So this is wrong option. So option B says let's use guard duty and then publish Amazon SNS notifications. Now Guard Duty monitors threats and generates security finding, but its focus isn't directly on EC2 instance vulnerability or compliance check. So this is not a correct answer in the case of, if you have to do an automated evaluation of security of Amazon EC2 instances. So that's incorrect as well. Let's look at if there is any other option that appears to be obviously incorrect. Okay, option D. Now, option D says use Amazon Event Bridge to detect and react to changes in the status of AWS Trusted Advisor check. This triggers action based on Trusted Advisor check, but these checks might not cover all necessary security and compliance requirements. So this is a kind of an incomplete solution. So that's wrong for me. Option D is wrong. And that leaves us with option C, use of Amazon Inspector with CloudWatch to publish Amazon SNS notifications. Now, this appears to be the correct answer. And if you can see in this particular option, Inspector performs automated vulnerability assessment of EC2 instances. It identifies the misconfiguration and potential security flaws. So this is perfect for, finding the vulnerabilities in an EC2 instance. And then CloudWatch will monitor the inspector's finding and publish notification via SNS when issues are detected. This allows for prompt remediation and compliance verification. So this is the perfect solution from what we have been given. Again, in this particular question, the answers are not very obvious. The correct ones are not obvious as well as incorrect. But if you analyze it in detail, you will understand that the option C is the correct answer. So correct answer for this particular question is option C, use of Amazon Inspector, Amazon CloudWatch to publish Amazon Simple Notification Service. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 24. This is a database question. On Amazon Aurora, a business is operating a database. Every nightfall, the database is inactive when the user traffic surges in early hours. Application that makes large read on database will face performance concerns. When reading from the database during peak hours, the program encounters timeout issues. Due to the lack of dedicated operation crew, organization needs an automated solution to solve performance concerns. Which activities should a solution architect take to ensure that database automatically adjusts to the increasing read load? And you need to select two options. A business is using a database. It's an Amazon Aurora database. And during the night, the database is inactive. But then suddenly in the morning, traffic is surging in early hours and performance from the database is not great. And the organization doesn't have any operational staff to do this activity. And they want an automated solution so that every morning, whenever in early hours traffic increases, they want the system to automatically react to it and give good read performance. So let's go through the options and let's see which are obvious incorrect options, and we'll then get to the correct one. Option B, it says increase the size of Aurora database. This is basically vertical scaling. Now, this might give temporary relief, but if the traffic surge is even beyond the size, you don't know what is the limit for the traffic surge. Are you going to need uh, twice the current database size, thrice the current database size? So we don't know it. So there's no point just adding unnecessary capacity as well, because there could be three scenarios. You might be lucky enough, have the traffic surge to the limit you have resized the database, but you cannot just rely on luck in this case. But the other two scenarios, which are highly possible, is you have over provision. So maybe you are being extra cautious and over provisioning the database to more than required. And that means you're going to unnecessarily pay for the capacity that you have not used or you're not going to use. Then there is a scenario as well where you are under provisioning, which is what more or less current scenario is, that you have provisioned the server to a capacity much lower than what is needed. So increasing the instance size is an incorrect option. You cannot just increase the instance size to a particular limit without knowing or without having any other mechanism in place. So option B is wrong. Option D is another incorrect option for me. What it says is migrate the database to Aurora multi-master cluster. Now, we don't need any reliability solution here. What we are needing is to improve the performance. So this particular solution is not going to help with read performance. What it will do is you are having multi-master cluster. So this will help you in disaster recovery, and it will give you availability. But this is not going to help with scaling the read capacity. So that's incorrect option for me. So option D is gone. Let's see if there is anything else incorrect. There is one more option looks like is available for reliability. So the last option, option E, it says let's migrate the database on Amazon RDS for MySQL in multi-AZ deployment. Now, so this option doesn't give you anything. Again, similar to option D, this might just increase the availability of the database, but it's not going to help with any read performance or scaling of read performance. So option E is also wrong. It's similar to D, just a different solution. And that leaves us with the migration to Aurora database serverless. That's option A. And option C, which is configure auto scaling with Aurora replicas. And we'll look at these options in detail. The problem that we had was we need to automatically scale reads during traffic surges. We need to improve the read performance. And how option A is going to help with that is migrating database to Aurora serverless is going to give you automated scaling. Aurora serverless automatically provisions and scales database resources based on real-time workload. So when the demand is low, it will scale it down. When the demand is high, it will scale it up. So it is perfect for unpredictable workloads, and you only pay for the resources you use. So this is going to solve your scaling problem to a very high degree. The second option, which was option C, to configure Aurora auto scaling with Aurora replicas. So we are not just going for one solution. We have to basically we had to answer two solutions. So there are two options here which can help with read operations and improving read performance. Now this is option C is like horizontal scaling. Aurora auto scaling automatically adds and removes read replicas. So you will have multiple read replicas depending on what you need on configurable metric basis, and this will distribute the read traffic across replicas, and it will improve the performance during peak hours. So what we are saying is your server itself will be Aurora serverless, which will do auto scaling within the database itself. But you are doing horizontal scaling as well by adding more Aurora read replicas. And when traffic is high, you can have multiple Aurora instances serving those read operations. So you have an automated read replicas, which would be again scaling up and down depending on what traffic you have. So these two options are going to give you a very good read performance for traffic surges and the problem that you have been given where your application is coming up from an inactive stage overnight. That's it on this question. Let's move to the next question. Question number 25. A business uses Amazon EC2 instances to operate an API-based inventory reporting application. The program makes use of an Amazon DynamoDB database to store data. The distribution center of the corporation uses an on-premises shipping application that communicates with an API to update inventory prior to generating shipping labels. Each day, organization has seen application outages resulting in missed transactions. What should a solution architect propose to increase the resiliency of the application? So let's look at what problem we are trying to solve here. So we have a shipping application. Let's say it's DHL is a company who has a shipping application, and they are accessing, and it's all on premises. And you also have certain services at AWS's data center. So your other part of application, which is taking an API request from the on-prem application and then updating DynamoDB database for inventory, is on AWS infrastructure. And what you're getting is you're getting an API request from the on-prem application for updating the inventory API. What also have been specified that there are application outages happening every day, and I'm assuming it to be on on-prem side. And what that means is whenever application outages are happening, the update inventory API call is not going through or not being called, and that's causing missed transactions. So that's your overall problem scenario. And we have done similar problems like these, and there is a keyword here, missed transaction. And whenever you have this missed transaction situation, what you do is you basically decouple the application. You decouple the application and you use Amazon SQS as your service, where then the on-prem application will queue up all the API requests at SQS, and then SQS will process these requests one by one and pass it on to the AWS solution, and the inventory updates will happen. Now, this probably is not the exact implementation of the solution. There could be a Lambda involved here, but the focus here is on decoupling the application so that the API calls are not missed even when there are application outage on, say, on-prem side. Now, all of this means your application will perform much reliably. It's decoupled. You don't have to worry about either of the system component being available. All applications can be queued up at SQS, and you will get rid of your missed transaction problem. So that's your answer. And let's see if we have that answer in the options given in the question. And yes, we can see our answer as option D, but let's eliminate other options as well. So the first one I will rule out is the option A. It says modify the shipping application to write to a local database. Now, this will offer some sort of increased availability because your application, which is calling API and the database getting updated, all is together, but it doesn't automatically scale read capacity or address timeouts. And we are basically saying then do everything on-prem, and that's not the point. The point is we want to use cloud infrastructure and then make this solution work better. Whatever application is sitting in on-prem, because probably the label printing application, which is what is on-prem, cannot be moved across to AWS. Maybe it involves some physical hardware as well. Hence, that part stays in the hybrid environment on-prem. The solution should involve how effectively we can handle this API request so that it is able to cope up with the outages that are happening on the application. So I'll rule out this option. Then the next wrong for me is option B. Option B says modify the application API to run serverless using AWS Lambda. Now, if it is serverless, it will offer scalability, it will improve the response times, but the core issue is about outage vulnerability. And if the application on the on-prem side is going down, its API will still have to call AWS Lambda, and the API calls are going to get lost. So it's not going to solve the main problem. So that's an incorrect option for me. Option B is wrong as well. Let's look at option C. Option C says configure Amazon API gateway to call EC2 inventory application APIs. Now, this is adding another level of complexity without actually improving the resilience. An outage in either API gateway or EC2 instance would still cause the issue. Now, in this case, even we are assuming that maybe there is an outage on AWS side. So just having an API gateway is not going to help, because the whole point is we need to decouple, and either of this application component gets, is not available, whether it is AWS or on-prem. We want to make sure that your application is reliable and your updates are going through, or at least queued up somewhere so that those could be processed whenever the application components are back up. So that leaves us with last option, which is option D, which we have seen in detail in the solution overview. Modifying the application to send inventory updates using Amazon SQS is the correct answer for this particular question. And I believe this was the last question of this particular episode. This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.